We're just going to go through this chapter, okay? First of all, what is a force? A force is anything that can change the velocity of an object, okay? So what I'd say about force is anything that can change the velocity of an object. Okay, I think we'll make that a bit smaller, won't we? Oop, let's see here. 22. There you go, that's a nicer one there. Okay, anything that can change the velocity of an object. Name an instrument used to measure a force. Well, if you go to your book, you might be able to find such an item here. Oh, what's this thing here? A Newton meter. A Newton meter is used to measure force. Force can be measured using a Newton meter. Okay, so look, there's our answer for this question here. Our force sensor. Okay, so that's our answer to the second question. So part B would be this answer here. There you go. Question B. What is the unit of force? Well, I think that's on the. I think that's also on that page. The unit of force is the Newton. Okay, and then we also can find the answer for part A here as well, if you really want to use that instead of the answer I used earlier. A force is anything that causes an object to accelerate, i.e. change its velocity. You could also use that one. What is the unit of force? The unit of force is the Newton. N-U-W, Newton. Okay, awesome. Next question. Name the scientist whose laws of forces are their basis for physics today. Well, I'm pretty sure it's Isaac Newton, but let's make sure. Okay, so we might move on to the next page here. Can't really find it just yet, so we might usually the scientist who discovers is on the first page of the question there. There you go, Isaac Newton, and it's called Newton's. Okay, so we'll go for Isaac Newton here. Okay. What would the effect of balanced forces have on the velocity of an object? Well, if the forces are balanced, the velocity will remain the same. So for part B, I suppose I should type it out. Size 22 font, we hope. So for part B, the velocity of the object will stay the same. Okay, all good. Give 3 effects that forces can have on a body. Well, I suppose we can look at the first part. We can say that we move. There you go. It can push, pull. It can cause objects to stretch, compress, twist, or change the shape of the body. So basically, take your choice out of the first couple. Okay, so this one here is a good example of the answer you might go for. So the 3 parts we can take from this is, I suppose what I'll use here is, can cause a body, massive font all the time, can cause a body to change velocity. It could compress a body or twist a body into a different shape. So look, there's 3 different things. Okay, complete the statement. Unbalanced forces cause a body to accelerate. Okay, so if you're wondering what that basically means, basically if I have a crate here, okay, and let's say 2 lads are pushing it. One lad is pushing it left with a force of 50 newtons, but a bigger, stronger kid is pushing it to the right with 70 newtons. What will happen is the block will move 20 newtons, will move with a force of 20 newtons to the right. The bigger force is usually represented by a larger, longer arrow. Okay, so the red arrow is representing the 70 newtons going to the right is bigger than the small arrow of 50 newtons going to the left. Okay, so that's part D done as well. Now, based on your answer to the above questions, predict what will happen if this aircraft is flying in air. Well, if you're flying in air, the airplane is, in most cases, bar the odd Harrier jet, fighter jet, which can go vertically upwards. Usually you're traveling right. Okay? So F1 is greater than F2. That is true. Now, is F3 greater than F4? No, if you're landing, it is. When you're landing, you start to descend, so that would mean that your force pushing downwards is greater than your force pushing upwards. But if you're flying level in air, no, we're going to say level, as in we're neither ascending or descending, we're neither going up or down. Well, this is false. They're equal to each other. F1 is equal to F2. Well, if F1 is equal to F2, your force right equals your force left, which means you're traveling nowhere. Airplanes don't generally do that, so we say false for that. F2 is greater than F1. False. That would mean you're going backwards, which airplanes can't be going backwards. Like, you don't see an airplane. Airplanes usually travel left to right in this case, but you don't see the airplane going back this way. No, that ain't going to happen. Okay. F4 is equal to F3. Well, that's true, because if F4 is equal to F3, it means it stays stationary. It's neither going up or down. So F4 equal to F3, I'd say is true. Now, if F3 is less than F4, that means that you're going upwards. And that does happen at the start of flight. But halfway through your flight, you usually stay at the same height. So we'll say that's false unless you're on your way, unless you're taking off. Okay. 31.4, name an instrument used to measure force. Well, I think we already have the answer for that one. Force can be measured using a Newton meter, also called a force meter or a force sensor. There we go, there's the answer for 31.4. Okay, next one. Diagram shows forces acting on truck moving forwards at 60 kilometers an hour. Which arrow shows the pull of the engine? Well, if the truck is moving this way and it's going forward and not in reverse, the pull of the engine is A. The air resistance is what's slowing down the truck. That'll be partially represented by B. The weight of the truck is what acts downwards, so that'll be D. The push of the truck on the ground. So when you stand on an object on the ground, your weight acts downwards, and you feel the ground keeping you steady, pushing you upwards. So that will be C. What happens if force A is greater than force B? Well, the truck will accelerate. So it's currently going 60 kilometers an hour, but if it starts to accelerate, it could end up on 62, 64, 66. Its speed could go upwards. What happens if force A equals force B? Truck will stay at the same velocity. Is that all right with you guys? Okay. 31.6. What is friction? Give two disadvantages of friction. Well, let's have a quick look at let's have a quick look through the book here, okay, and see what friction is. There's usually a good definition of it somewhere here. Okay, so what is friction? Well, if you look at friction here, friction is a force that opposes motion. Basically, when one object slides over another object, the friction tries to stop the movement. Friction always opposes the motion of the object. The rougher the two surfaces are, the greater the friction. Okay, so your answer there could be friction is a force that opposes motion. Okay, so we'll send it to the current page, and there is your answer of part A. Now, give two disadvantages of friction. Now, where would we find that in the book? Okay, so we want to Okay, so friction, I suppose, can wear your tires out, so and ball bearings out. So disadvantages of friction. Take any of these ones here. Okay, so these are your disadvantages of friction. So friction slows these things down. A ship finds it difficult to travel through water because of friction. Aircraft move at much greater speeds because there's less friction in air than water. Friction wastes energy. To overcome the force friction, an engine of a car must burn a lot more fuel to maintain a car's speed. Also causes wear. Over a period of time, car tires become worn and need to be replaced. The same happens on the sole of our shoes. Okay, so there's our disadvantages. How can friction be reduced? Well, let's see, how can friction be reduced? Well, we go back to the last page here, towards the very bottom. Friction may be reduced by the following. You can have lubrication. The oil is placed between two surfaces. The oil fills the humps between two surfaces, stopping them catching on each other. Ball bearings. Two small steel balls are placed between two small objects. The ball bearings roll over each other instead of sliding, reduces the friction. Streamline. As discussed before, the air can oppose the motion of moving objects. This is called air resistance. This occurs because moving objects have to move in the air in front of its way. Air resistance can be reduced by streamlining. Okay, so look, there's our answers to how can friction be reduced. Give two advantages of friction. Well, we just seen the advantages of friction on the next page here. So let's give two of these out of the three answers here. Okay, so let's see. Friction allows brakes to be used. Think of what happens if a moving car tries to stop on ice, which has very low friction. Friction between your shoe and the pathway allows you to move. This was more difficult to walk on ice. It slows down rain and hailstones. Without friction in the wind, as in air resistance, rain and hailstones would cause a lot of damage as they'd be moving at enormous speeds. There we go. All very interesting questions. Okay, 31.7. Find the weight of the girl using the following items. Sorry, take the value of G. Now, weight equals mass multiplied by gravity. So it's 55 multiplied by 10, which is 550 newtons. 1,000 kilogram elephant is 5,000 multiplied by 10, which is 50,000 newtons. Okay. Finally, a 200 gram packet of cheese. Well, you got to change that into kilograms. It's 0.2 kilograms multiplied by 10, which would be a weight of 2 newtons. And a 100 gram apple is 0.1 kilograms multiplied by 10, which give you a weight of 1 newton. Okay, 31.8. The mass of a book of weight 10 newtons on the surface of the earth. Well, if weight equals mass multiplied by gravity, mass must equal weight divided by gravity. So weight is 10 newtons, gravity is 10, this means a mass of 1 kilograms. The weight of 5 kilogram bottle of water on the surface of the earth, well, that'll be 5 multiplied by 10, which gets us 50 newtons. Finally, part C, the force needed to give an acceleration of 2 meters per second to a mass of 50 kilograms. Well, there's a formula for force. Force equals mass multiplied by the acceleration. So force equals mass, ma. Force equals mass, which is 50 multiplied by 2, which is 100 newtons of force. Okay, 31.9. Name 3 variables that affect the weight of an object. So we go into weight section. Objects with, so let's see what affects weight. The weight of an object at any surface on a planet depends on 3 factors. Here we go. So, the weight of an object on the surface of a planet depends on any three of the following factors: the mass of the planet, the distance from the center of the planet, and the mass of the object on the surface of the planet. Okay, now 31.10. Calculate the force needed to accelerate the following objects. So it's going to be, remember, force equals ma. So it's going to be 2 multiplied by 100,000, which is 200,000 newtons. 1,000 multiplied by 1 is 1,000 newtons. 2 million multiplied by 5 is 10 million. That'll be 10 million newtons. And finally, 80 multiplied by 200 is going to be, what's 80 multiplied by 200? 16,000 newtons. Okay. Next one. A student carried out experiment to investigate the extension of a spiral spring when changing the applied force. How did the student measure the applied force? Okay, so here's what we're going to do. We're going to go back to this question here. Oh, sorry, we have an experiment we need to find out. Here it is here. Okay, so what happens is when you get a spring, you put a weight on it, the spring extends by a certain amount. So if you put a 1 Newton weight onto a 1 Newton weight onto a spring, it might extend 5 centimeters. This means 2 Newtons should probably make it go 10 centimeters. Okay, the more stretched the spring is, the more likely it is the more it pulls back harder. Okay, so let me show you what I mean by that. Okay, so guys, just looking at this here, okay, so if we start off with both springs, and both springs are the same, okay, so you can see both springs are identical. They have the same, this is the power of the spring. And basically if I pull it, so let's say I pull it 50 Newtons worth of energy, okay, and I pull the bottom one 100 Newtons worth. You see that the extension on the bottom one will be twice as large as the extension on the top one, okay. So we get our displacement here, okay? So this one isn't displaced at all. Now, what happens if we go another 50? Actually, we should start off at 0. My fault, lads. We'll start off at here, actually. See the way both springs are the same length. Okay, so this is neutral position here, okay? Now, what happens is if I go up 50, I stretch the spring by this much here. See the green arrow? But if I stretch it, if I do 100, I stretch it twice as far, okay? So that's how you can do Newton's law here, okay? So back to the question that we originally had. How does a student measure the fly's force? We can either using a Newton meter. So you can pull on the spring and you can measure it using a Newton meter, as I showed here. This is a Newton meter and it tells you how much force you're putting on it. Or you can apply weights onto it. So in the book as well, what it does is, in the book you can use weights, so you can put on weights, 1 Newton weight, and then 2 of those weights would be 2 Newtons. Basically 100 gram weight, when you multiply it by 10, is roughly 1 Newton of force, okay? So you have these weights which are called Newton weights, and you can put them on to get the force you require, okay? So you can use a Newton meter or weights. How did the student measure the extension of the spiral spring? Well, you can see here that he's using a ruler to measure the extension on the spiral spring. So using a ruler. Okay, the following results were attained. Find the extension of the spring. Well, the extension starts off at 25. Okay, so we'll call that Doesn't give us, but we can find it here. So that's 10. That's 20. This one here. So guys, I think this question might be slumping up again to plot extension versus force. What did the ruler start off with? Okay, so this is lacking a bit of information. Okay, so sorry guys, this question is lacking information. It's a poorly written question. It needs to tell you the length of the spring at the beginning. So for argument's sake, we'll just say the length of the spring at the beginning is 20. Okay, so if you put 1 Newton on it, it goes to actually 15, my fault, 15. It's such a poorly written question. So if you have 0 newtons, you should have 15, okay? So 1 Newton gets you 25, that's an extension of 10. 2 newtons is 35 centimeters, it was 15, so that's 20. 3 newtons will be 30, 4 newtons will be 40, 5 newtons will be 50, 6 newtons will be 60. Now I gotta draw this on a graph, okay? So the following points would be, okay? So we do force on the bottom, which is gonna be 1, 2, 3, 4, 5, 6, and 7, okay? So these points here. So these ones here, guys. Okay, make this quite small. Okay. No, of course not. How would that work? Cut. There we go, there's my diagram there, lads. Okay. Now I have to go up in the next one. I'm going to go up 10, 20, 30, 40, 50, 60, and 70. Okay. So 110. No force means no extension. That's just the way it is. 220, 330, 440, 550, 660, oh sorry, 760, 110, 220, 330, 440, 550, 660. Oh sorry, I'm wrong. 6 is 60, okay? So it doesn't go up as far as 7. And then we draw the line, and there is our graph. So this is extension measured in centimeters. This is force measured in newtons. Okay, sorry about that question, guys. It's a bit of a tricky one there, okay? And what else do we have in the question? What's the shape of this graph? A straight line. Okay, what does the shape of the graph tell you between the relationship between extension and applied force on the string, on the spiral spring? Well, if you go back to here, what you'll see is that the larger your force you put on, it's going to be the larger your spring. So the larger the extension, the larger the force, the larger the pulling force, the larger the extension on the string. Okay, and that's us.